Hello, greeting students. Welcome to the chemistry offline classes. We are still in Unit 2, and today we're going to be busy with the classification of acids. I trust that you're all well, so get ready, turn your books to page 42, and let's start. The classification of acids. Acids do not all ionize or dissociate to the same extent. Some acids ionize completely in water and others ionize partially in water. We should also know that different acids may produce different number of hydrogen ions. They may produce 1, 2, or 3 hydrogen ions. Knowing that we classify the acids according to the strength and according to the number of hydrogen atoms produced. The classification according to the strength. We may classify an acid as strong acid or as weak acid, okay, according to the strength. According to the number of hydrogen atoms, we may classify an acid as monoprotic, diprotic, or triprotic. Okay, that is the full classification of an acid. An acid may be classified according to the strength and according to the number of hydrogen atoms produced. According to the strength, we have strong acids, we have weak acids. According to the number of hydrogen produced, we have monoprotic, diprotic, or triprotic acid. Let's go a little bit deep to the classification according to the strength. An acid can be strong acid or can be a weak acid. Strong acid is an acid that completely ionizes in water. In case of weak acids are acids that do not ionize completely in water. In that case, they ionize partially in water. For the strong acid, we have the formation of positive and negative charged species. But then in weak acids, we have ions recombining to molecules. So we have a mixture of ions and molecules. It means that the molecules didn't disassociate completely. I have two examples, one for strong acid and the other one for weak acids. Hydrochloric acid is considered as a strong acid. Why? Because if we pass hydrogen chloride gas through water, we end up having the complete ionization of hydrochloric acid, giving us hydrogen ions and chloride ions. As we can see using that image, we have the hydrogen ion and we have chloride ions. There is no molecule, only positive and negative charge. This hydrogen plus and chloride ions. There was a completely disassociation of hydrogen gas, hydrogen chloride molecules. For that example, we have hydrofluoric acid that did not disassociate completely in water. We have hydrogen ions, we have fluoride ions, and we still have hydrogen of fluoride molecules. Okay, so the molecules they recombine and remain as molecule. We have a mixture of ions and molecules. We may conclude that hydrofluoric acid is a weak acid because it didn't disassociate completely. I have other example for strong acids and weak acids. For strong acid, I have hydrochloric acid, hydrobromic acid, nitric acid, perchloric acid, and I have sulfuric acid. Okay, For weak acids, I have hydrofluoric acid, hydrocyanic acid, carbonic acid, sulfurous acid, phosphorus acid, and acetic acid. As we can see, if we try to ionize the HNO3 or nitric acid, we are going to have the hydrogen ion and the nitrate ion. It completely disassociates into positive and negative charge. But then if we try and do the same for acetic acid, we end up having the hydrogen ion, but then we will remain with CH3COO molecule. So it means that it didn't disassociate completely. And the same happens to those acids. Let's classify the acids according to the number of hydrogen atoms. If one hydrogen ion is produced, the acid is called monoprotic. If two hydrogen ions are produced, the acid is called diprotic. If three hydrogen ions are produced, the acid is called triprotic. Okay, so that is the classification of an acid according to the number of hydrogen that is produced during the ionization. And I have three examples here. The first one is our friend hydrochloric acid. When it passes through the water, we have the formation of hydrogen ion and we have the formation of chloride ion. As you can see, we have positive charge and negative charge species. For sulfuric acid, we have the formation of two hydrogen ions, and then we have the sulfate ion. Okay, that is a strong acid. Okay, you should bear that. For the phosphoric acid, we call it a triprotic acid because when it dissociates in water, we have three hydrogen ions and we have the phosphate ion. Okay, so we need to balance the equation. For example, two hydrogen atoms, one sulfur atom, and four oxygen atoms in the left hand side. We also have four oxygen atoms in the right hand side. Okay, I have few examples for the classification of acids according to the number of hydrogen atoms. We have monoprotic, so hydrochloric acid, nitric acid, hydrocyanic acid. Okay, for diprotic we have sulfuric acid, sulfurous acid, and carbonic acid. For triprotic we have phosphoric acid and we have arsenic acid. Means that the arsenic acid will give three hydrogen ions produced. The carbonic acid will yield two hydrogen ions. The hydrocyanic acid will yield one hydrogen atom when ionized with water. Okay, so I have three acids and I need your help to solve that. We need to write the chemical equation for the dissociation of those three acids. Let me give you 30 seconds to try the first one. Okay, so for nitric acid, that is our R, we're going to have the hydrogen ion, right? And then we are going to have the nitrate ion. There is only one, there is nothing here. It means that the nitrate ion negative. Okay, so let's try to check if our chemical equation is balanced. Hydrogen 1, hydrogen 1 nitrogen atom, 1 nitrogen atom, 3 oxygen atoms, 3 oxygen atoms. So we call it a monoprotic oops acid. Okay, second one, we have carbonic acid. If carbonic acid is being dissociated in water, we have the hydrogen ion being formed or produced, and then we have the carbonate ion, that is CO3. Can you see that we have two hydrogen atoms? These two is going to give us a highlight of the charge of the carbonate ion. It means that we have a 2 minus. Okay, now let's try to balance. There are two hydrogen atoms in the left hand side, but only one hydrogen atom in the right hand side, meaning that we need to have 2 beside the hydrogen ion. In that case, 2 hydrogen ions, 1 carbon, 3 oxygen, 3 oxygen. So that is diprotic acid. Okay, good. Then the last example or exercise is the acetic acid. If it's being dissociated, we have the hydrogen ion, and then we have the arsenic ion. Okay, so we have AsO4. As I told you, the number of hydrogen will highlight the charge of the acid. It means that we have a negative charge. Okay, let's try to balance 3 atoms of hydrogen, 1 atom of hydrogen, meaning that we need a 3 beside the hydrogen. Now we have 3 hydrogen atoms, 1 arsenic, and 4 atoms of oxygen, At the end, we know that the acetic acid is a triprotic acid. Okay, that is it. That is the final answers. We have H, only one hydrogen ion being produced. We have 2 hydrogen ions being produced and 3 hydrogen ions being produced. So nitric acid is monoprotic, carbonic acid is diprotic, and arsenic acid is triprotic acid. That is it for classification of acids. The homework is to write the complete chemical reaction for hydrocyanic acid and sulfurous acid with water. I remember that I'm going to send the homework full Fedena. So I need you to write the balance equation, the charge, okay, be aware of the charge of the ions, and I also need you to give the state, whether it's aqueous, solid, liquids of the constituents, and you should also state whether it's monoprotic, diprotic, triprotic, or it is a strong and weak. So you're going to have two. Okay, so either, for example, you may say hydrocyanic acid is strong and monoprotic, okay, or sulfurous acid is weak acid and triprotic. Okay, so thank you for being part of that class. See you in lesson 3. Bye.